example 4, find the limit. So we're going to find the limit for each of these one-sided limits by first of all graphing the function. Notice that the function is the same for each of these. Okay, so first of all, let's see if we can figure out the vertical asymptote. The vertical asymptote is going to be x equals 1, because when I plug 1 is where the domain is not defined. So that's either going to be vertical asymptote or it's going to be a hole. Okay, in this case it's going to be vertical asymptote. Now the horizontal asymptote. Well, since the degree of the denominator is the degree of the numerator is greater than the degree of the denominator, we don't have a horizontal asymptote. But we might have a slant asymptote. And to figure out what that slant asymptote could possibly be, we are going to use long division. So we're going to take x minus 1, divide it into x squared minus 3x. So we need to think, okay, what do I need to multiply x by to get x squared? That's going to be x. X times x is x squared. X times negative 1 is going to be negative 1x. Next, I'm going to subtract. So x squared minus x squared, that's going to be 0. Negative 3x minus negative 1x is really negative 3x plus 1x, so that's going to be negative 2x. Next, I'm going to put a plus 0 here, bring that down. And then I'm going to start this process over again. I'm going to think, okay, what do I need to multiply x by to give me negative 2x? That's going to be negative 2. So I'm going to take negative 2, multiply it by the x. That's going to give me negative 2x. Then I'm going to take negative 2, multiply it by negative 1. That's going to give me positive 2. And then again, I'm going to subtract here. So I'm putting this in parentheses. So the negative 2 minus a negative 2x, that's going to be 0. 0 minus 2, that's going to be negative 2. So now I have plus negative 2 all over x minus 1. So this is known as the quotient. Okay, and this part here is going to be my slant asymptote. So I'm going to have a slant asymptote at y equals x minus 2. So now I'm going to use the vertical asymptote and the slant asymptote to begin to graph this function. So vertical asymptote at x equals 1. And horizontal asymptote at x minus 2. So I'm going to start at negative 2, and I'm going to go up 1 over 1. And I can go this direction as well. I can go down 1 and 1 to the left. So now I've got my slant asymptote, I got my vertical asymptote. Now what I can do, I can plug x values into this function, okay, to see how the rest of this graph looks. So I'm going to look at my vertical asymptote. I'm going to pick an x value to the left of it. So let's pick 0. When you plug 0 into this function, the numerator would be 0, the denominator would be negative 1, so this is going to be 0. So if I have a point here, this is going to hug the vertical asymptote this way, and it's going to hug the slant asymptote that way. So the shape of this graph is going to look like this. On this side of the vertical asymptote, I also need to test a point on the right of the vertical asymptote, so I'm going to test 2. When I plug 2 into this function, I'm going to get 4 minus 6, which would be negative 2. And then I would get 2 minus 1, which would be 1. So this is going to be equal to negative 2. So negative 2. So negative 2 would be here. Okay, so now I see what the graph of this function looks like in blue. Now I can find the limit here. So first of all, let's find the limit. I'm going to call the function f of x as x approaches 1 from the left. Okay, so as x approaches 1 from the left, that's going this way. That's going towards positive infinity. Also, they want us to take a look at the limit of this function as x approaches 1 from the right. And when you're approaching 1 from the right, this will give us negative infinity. Okay, this problem doesn't want us to do this, but remember, using limits, this is telling us that we have a vertical asymptote at x equals 1, since as x approaches 1 from the left, it's going towards positive infinity, and the limit of this function as x approaches 1 from the right is going towards negative infinity. So that is how you describe a vertical asymptote using limits in calculus.